So our topic is star delta combination. Let's say this point is A. We have a resistor here. This point is B. This point is C. Okay. And the resistors, this resistor is RAB, that is between AB. This is RBC. And this is RCA or AC. This type of combination is called delta. See, this is delta. And we have a combination equivalent to this, which is called star. Let the nodes be same, A, B, C. This is RA, this is RB, this is RC. Now, the beauty is that this type of circuit can be converted to this, and this type of circuit can be converted to this. How? We have equivalence. RAB, if you want to know what is RAB in terms of this, then RAB is written as, first of all, this into this, RA into RB plus RB into RC plus RC into RA. Multiply all them in couple, RA, RC, RC, RB and this one. By, when you are talking of RAB, then the resistor that is in front of this, which resistor? In front of this we have RC, so we will write RC. Okay. Similarly, you want to know what is RCA. RCA, this one. Again, this is common. That is RA, RB, RB, RC, RC, RA. And you have to see, we are talking of CA. So, which resistor in front of this? See, in front of this we have RB. So, this is RB. Clear? Similarly, you want to know what is RBC. Now, you must have understood RBC. This thing is common, RA, RB, RB, RC, RC, RA. And the resistor in front of this is RA. So, this is, if you have a, if you have a circuit in this star combination, you have resistors, this, take this node, then you can convert it to this type of circuit. We'll see an example to understand this, but for the time being, understand this is how we convert. Similarly, if you have a circuit in this form, how can we get in that form? You want to see about RA. What do you have to do? This is RA. So, you multiply this into this, that is RAB into RCA, and then add all these three, RAB plus RBC plus RCA. So, this is how you get RA. Now, if you want to see what is RB, again I told you RB, it is here. So, this into this, that is RAB into RBC by adding them all. RAB plus RBC plus RCA. Similarly, we want to see what is RC. So this into this, that is RBC into RCA by adding them all, that is RAB, RBC plus RCA. Okay, so this is called star delta combination. Let's see a quick example. Now, we have to find the equivalent resistance across A and C. See, this figure, if you try to see, let's say this is N, then this is basically what? See, this is N, this is A, this is C. So, this is 4, this is 8 and this is 2 ohm. So, this is in star combination. We can convert it to, see, we can convert it to like this, delta combination. Let this be A, this be C, and this be N. We want to know what are the equivalent resistances. What will be the use? We'll see next. See, we saw we want to have this into this plus this into this into this into this, and when you are talking of this, we'll divide it by this. So let's say R not equivalent, let's say Rx, which is this into this. So 4 into 8 plus 8 into 2 plus 2 into 4. So this is 32 plus 16 plus 8. So what this is 32 plus 8, 40, and 16, it is 56. Okay. Now, when we are talking of this, this will be 56 by 2, that is 28. When we are talking of this one, we'll have 56 by this 4. So 56 by 4 will be 56 by 4. So it's 1 and 4, 14. So this is 14 ohms. And this one 56 by 8. So this will be 7 ohms. So our equivalent delta circuit resistors are 28, 14 and 7 ohms. Okay. Now let's fit this combination here. I am rubbing this. Now we have a 28 ohms resistance here. Then we have between this and this. What is this? 7 ohms. And this 14 ohms. Okay. We have converted star to delta. Now if you see, these two are in parallel. See, 3 and 7 are in parallel. When 3 and 7 are in parallel, what will be the equivalent resistor? This will be 3 into 7 by 3 plus 7, that is 10. That is 2.1. So this can be replaced by a 2.1 ohms resistor. 2.1 ohms. Then this is 14 and 12. See, 14 and 12 are in parallel. So this can be replaced by 14 into 12 by 14 plus 12, that is 26. So what we can have 14, 7, 26, 13. So what is it? So this comes to 6.46. So this can be replaced by 6.46 ohms. Now these two are in series. So what do we have? 2.1 plus 6.46. So what is 8.56. So this can be replaced by an equivalent resistor of, what was it? 2.1 and 6. So 8.56. 8.56 ohms resistor. Now these three are in parallel. See. So what can be the result? That is 1 by 8.56 plus 1 by 28, 1 by 4. Or what you can do, let's take this one first. 28 and 4. So 28 and 4 by 32. So what do we get? 4, 7, 4 into 8. Okay. 4 into 2. So this is 7.2. So we can have an equivalent resistor of 7 by 2, that is 3.5 ohms. Now we have 3.5 and 8.56. So this will be 3.5 into 8.56 by 3.5 plus 8.56. Let's calculate this. So this comes to 2.48 ohms. So if these two are the nodes, these two, it can be replaced by a single resistor of 2.48 ohms. Okay, so we have used delta star conversion. This is very useful in many cases.